Well, hi, welcome to my shop. This morning I'm starting on a new project, a really big project here. This is a 1929 Victor 245 amplifier, and the receiver I believe is called an R-45 receiver. Receiver, power supply, and amplifier, and of course a gigantic cast iron speaker out here. Wow. So this was a top of the line, or nearly the top of the line, receiver and record player, I guess, in a console. Well, I do not have the console cabinet here, I just have the componentry here. This was a really expensive thing back in the day, and top of the line, or nearly top of the line for sure. They made a lot of these. These were really popular. I think there were 300,000 of these guys made. So it's not too surprising that a good number of them have survived all the way to today, because they were top of the line, so people put a lot of money into it and they took good care of it and had a nice look. So it's been preserved in many homes as a piece of furniture, maybe not operating, and that's why today we can find so many. And this is generally true of top of the line type equipment where a lot was manufactured. So how am I going to approach this? I think today my job here is just generally, what is my job with all this anyway? I've been told by the owner that this essentially works, and what he's interested in is that it's working at peak performance, and that there's nothing wrong in it that is causing damage to itself. For instance, the tubes are not under undue stress or something of that sort. Or there's components in here, a capacitor is the obvious one, whose failure might cause damage to other important components like coils. So finding these risky old parts and getting rid of them, and any performance drags, which again would be probably from older capacitors that are in here. Now, I haven't really looked very closely. I've looked under here, and sure enough, there's a couple of very old capacitors and more. It's all old stuff under there. I have not looked inside this. I'm starting right from scratch here. So along with getting familiar with this whole thing, I'm going to be testing all the tubes right off the bat. Now, normally it's not my practice to test tubes in a radio right away. But I think it makes a lot of sense in this case. A lot of these radios have the same tube over and over and over again. As for instance, the receiver here, and there's some spare tubes in here. I believe the owner purchased a set of tubes, and I believe these are the originals out, and this is the purchase set, I believe. So if we look, it's a number 26, a number 26, a number 26, 26, and a number, take a guess, 26. This is a 227. I think this is a 227 here. These are 245s, two 245s if I want to use the whole number. And this is a number 80, or I believe it's numbered 280 at this time. So are any of these tubes original? It's not very likely. Radio's made it all the way to today with its absolutely original tubes in it. These tubes do not have long lives. So if the radio was used a lot, almost certainly it was being serviced with the replacement of tubes. That was a big deal. So it has this aluminum cover we can take off once the tubes are out and look under. And if we look under here, I'm not sure how well I can do this. Let me drop my camera down here. A little hard to see, but some of the mechanism can be seen down under there. So you can see some springs up in there and some other stuff and some levers going into these metal cans that are underneath here. So when you tune this radio, you're working a mechanical control that's moving this stuff. And inside each one of these boxes there is something moving, and I'm pretty sure this is a reluctance tune. That's a coils in here that are being tuned. So let's see, what's this? This is the antenna and the ground, and this over here is the phono input. Take a look right on the top here. You see kind of an interesting image right on there. Yeah, I think in the modern day they wouldn't bother with. You know, I suspect when this radio was built, the guys who were designing it and building it really thought this was the limit of radio technology. It couldn't get any better than this. And people still think that way today, of course. So that's why I think they put a huge amount of effort into this radio. The manual for it is incredibly detailed. But that also indicates in the very, very detailed manual and the encouragement that's all the way through it, you know, to go ahead and carefully do things to your radio, indicates how much service something like this really did require. You know, as opposed to, say, our ultra-modern equipment we have today, which really the only service a lot of modern equipment gets is a trip to the garbage dump. There we go. Okay, now I got a lot of tubes. I'm going to start with these spare ones, I think. Why not? So these are the ones that I believe the owner removed on the basis that they were bad. I don't know how he concluded that. So, of course, when you buy tubes, they're always claimed to have been tested, and I know from my own experience, testing tubes is not a simple matter. Sure, seems simple, can be done simply, but there's a lot more to it than meets the eye. So, what's on sale here? It's a crazy $2.88 a pound for a butterball seasoned turkey. It's crazy. The turkey itself is crazy. Okay, so the tube tester we're going to use, it's going to be this guy here. This is my go-to tube tester, but I do have two other excellent tube testers I could use too. But this is the guy we're gonna use, and let's start. What's the big sale here? Snuggle Plus. Okay, here we are. This looks like a number 80 to me. Number 80 right on it. So this will be the rectifier tube. Number 80s were used for a long time. This tube, I'm sure, is nowhere near as old as the unit itself. So number 80. Let me just hunt that down. Number 80. So here we are. Very important. 5 volts on the filament. JR030000300. Rectifier tubes are very simple tubes. Bias is set to 20. P3 rectifier. Put that on English, and we're going to read this as good or bad, or yeah, good or bad. That's the test, I believe. Okay, I think we're ready to go. Just quick double check. 5. Absolutely correct. JR. Good. 03000. Perfect. English. I got this wrong. Bias is 0. English is 20. Ooh, I just got that wrong. If you don't set the English correct, the meter will not be accurate. Good or bad, it won't be accurate. Okay, here we go. I don't even have this plugged in yet. I don't think. Yeah, it's plugged in. Here we go. Switch on. Now again, what prompted the owner to replace these tubes? I don't really know. I just suspect that a new batch would be better. But of course, really, there's not many really new tubes of this vintage anymore. They've almost all got mileage on them. Okay, check for shorts. two-part tube. We're checking the first part, and it comes up well into the good. Okay, the next part is checked by changing this to 15, oddly enough, and flipping this to 2. Now we'll check the other half. It's a two-part rectifier tube. There we go. The very same. So I think we've got a pretty good number 80 here. Now what we'll do is we'll test the one that's in the amplifier. It's in the power supply of the amplifier. Now this tube is nice and clean. It's so clean the numbers are gone on it. Oh, there we are. 80. You can see it right there. So again, this is not the oldest version of this tube. There we go. And what I mean by that is an older version of this tube would have a different number on it. It wouldn't say 80, it would say 280 or something like that. Okay, looking for shorts. Nope. We're doing the second half first. So that's a little higher than the last one. The last one came up just above the G. So what we're really checking in this kind of test is how capable the tube is to emit electrons off of its cathode. That's basically what we're really testing. Is the cathode worn out? That's kind of what it boils down to. Especially a hard-working tube like a rectifier tube. So this is testing even higher. Let's just go back. So 2. So the one tests just a little bit higher than the other. But this is a good tube, for sure. Put this back in the amplifier here. Okay, now just brought up another microphone here. Okay, now that's it for 80. So if we do the 26s next, there's a whole raft of them. So let's do that. So we'll look for number 26 here. 26, there it is. The filament voltage for this tube is only 1.5 volts. So everybody careful. JR 3567. 3567. 0. 10 on the bias. 67 on the English, if you care to use it. Let's try that again. One of the things about these roll charts is they roll while I got that completely wrong. It's all wrong. So JR is correct. 3200. 32. Wow. Right? It's just so easy to make a mistake. 43 on the bias. 56. I'm going to keep my finger on the roll chart here. Press P4 to read the mutual conductance. A reject point is 725. 3000 scale. 725 is about here. So if the pointer doesn't get above here, the tube is bad. And a good one should read 1150, which is up around the E here in the word replace. Replace good doesn't mean anything. I have this set for an actual measurement. Okay, we'll start with the first 26 here. This is coming out of the radio. It's not coming out of the grocery paper, grocery ads. Here we go. 1.5, 26. Be absolutely sure of everything. In she goes. Now these older tubes have a higher risk of having gas in them for a couple reasons. One is an atmospheric leak inside of the bulb, usually through the pins. And another one is gases produced by the components inside the tube themselves, kind of off-gassing a little bit. So we can study this up a little closer, but for now I'm not performing the gas test. I'm just noting that it could be a problem. 3,200. We're ready. Okay, so you see the short light flashing, which is a good sign. 725, 1150. So 7. So this is reading 8, almost 900. So I'm going to label and track all these tests, and what I'll do from here, video-wise, I'm just going to show you the results of each tube as I go through it. Okay, so this is how this is going to work. Each tube is listed up here. This is the first tube, so the first listing. This is a 45. It's a 45. R1 means it's from the radio. It's not spare, and it's tube number 1 of the 2. There's two 45s, so it's 45 tube number 1. That's what's going on up here. This marks, this little guy here marks the minimum that can be expected from the tube. So I don't have to comment anymore. I'll just do the test, boom, 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 down the sheet. This thing will move around as the settings change a little bit. So here we are. First tube. .45. Two spare 45s here. I'll be testing next. Okay, so this is the last tube. This is the 227, the detector tube. And that's the minimum rating there, so it's coming in a little higher. Okay, so I've done all the tubes here, but I'm going to do the first one again. This is R1 going in. The last time I did this, it read 1300, and I just want to verify that the test has been consistent. So we'll see if we get 1300 again. Don't. And the reason for this is in the middle of testing, like an idiot, I adjusted the line adjust and brought it down quite a bit. Dumb. That's from testing rectifier tubes and forgetting I put the line up. So a couple of the earlier readings were probably high, probably the first two 45s in fact, because I corrected it after that. First two 45s testing around 13 and 1400, but now at 1000. So we got basically, well, I'll give you the results when I finish them up. Okay, here's the results. So these are the tube numbers. A lot of these have a 2 in front of them. 226, 245. I actually wrote the 2 here, 227. These are the stickers I put on the side with some masking tape so I can identify them later. This is the result, obviously, taken from the mutual conductance test, except for the rectifier tube. And this is what the tube tester
says is the rejection point or the normal value. So you reject this tube at 1165, anything under that, reject it, reject it. Or if it's a pretty good tube, it's going to show up at 1850. It could even show up quite a bit higher in some tubes. So, but that's not the story here, that's for sure. So now I corrected these. Whoops, this one's supposed to be 1150. Oh, let's be nice to it. We'll say 1200. So the first couple of readings I took initially, I took with the line adjust wrong, and I've gone back and I've re-corrected these three readings which were off. I put the tubes back in and tested them again. So here we go. Let's start with the two rectifiers, the two number 80s. They both test good. They're both functional. Either one would do the job. Now we have a couple 45s that were in the radio. These ones are testing at 1000 and 1200, or maybe it's 1150. And you can see they're just below the minimum or right at the minimum. It doesn't mean they won't work, and it doesn't mean this tube tester is absolutely foolproof on these tests either. But I think that's how we would interpret this. These tubes are close to being worn out. They're output tubes, they work hard. Now all these 26s that are in there, there's some surprising results. So 700 is the minimum you want anyway. So that's over the minimum by a little bit, but that's way under. That's at the minimum, it's way under. That's just below the minimum, that's way under. This is way under too. A tube with a 50, this is not going to work in the radio. You might as well not plug it in there. With this tube in the radio could not have worked. That's what I believe, unless something weird has happened. I can't imagine what that is. We have two spare 45s, which is great because the 45s are the output tubes. They take a beating. And you can see these are both, again, similar to everything else, just a little below the minimum. And then the last one, a very important tube, the detector tube, is coming out actually above the minimum in what would be normal for a tube that's halfway through its life or something like that, somewhere between 1000 and the 630. So the bottom line here is, let's see, if we've got a spare 26 at 250, it's no good. And we have one 26 we must get rid of. Put the 250 there would be better. And then we'd have nothing under 250 through here. So, but this tube number 6, has got to go. Be interested to do some more tests on that and try to figure out what has happened to it. Did it get gassy, or is the cathode worn out? Don't know. So, in terms of the amplifier, now the amplifier runs with the two 45s, which are okay, the 80, which is okay, and one 26 used as an audio tube. So the thing about these 26 amplifier tubes here is they're pretty good at audio frequencies, but lots of trouble when you try to amplify radio frequencies with them. So it could be a number 26 in a radio frequency position has a lot of trouble. Maybe this 50 in a radio position, not going to work well. But in the audio position, this may work. Frankly, I doubt it. I think it's more likely maybe here. This 250 just may not work in the radio frequency amplifier, but as an audio amplifier, it may still work. So we can play around, move these around. That's a typical thing in these radios. It even says right in the operator's manual, move your 26 tubes around until you get the best result. But you know, with how many are in there? 1, 2, 3, 4, 5. 5 of them. You know, how many ways can you place 5 tubes? That would be 5 factorial. That's a lot of combinations. You'd have to try to find the best combination. Of course, we are using a tube tester here, so we know which tube is better, and we can eventually place them where in the radio circuitry where the best tube should be. And I think the manual actually hints at that. So there's the story. Amplifier probably going to work with the tube that it's got. 26 number 1. Yeah. So you see what's happened is all the best tubes are in the amplifier. And the radio's been forsaken. Okay, I think that's the story of the tubes on this radio. And I think that's it for this this particular video. Next step is going to be looking more closely at the amplifier. I think we'll start with that, of course. And we'll leave the radio out of the picture for now. and probably replace a couple of components underneath and try it out somehow. I don't know how you can power this up. Do you have to have the radio plugged in? Look at that monster. Holy smokes, man. That's no USB port. And with that, we'll call it quits. Thanks a lot for watching, and I'll see you on the next video.